Welcome to the fascinating world of quantum computing. In this video, we'll explore how quantum computers are set to revolutionize technology as we know it. Unlike classical computers, which use bits to process information, quantum computers harness the power of quantum bits or qubits. This allows them to solve certain problems much faster than traditional machines. As we embark on this journey, we'll break down complex concepts into easy-to-understand ideas, making quantum computing accessible for everyone. Let's start by understanding what makes quantum computing so unique and why it's generating so much excitement in the tech world. The heart of quantum computing lies the qubit. Unlike a classical bit, which can be either a 0 or a 1, a qubit can exist in a superposition of both states at the same time. This property enables quantum computers to process a vast amount of information simultaneously. Imagine flipping a coin, it can be heads or tails, but a qubit is like a spinning coin, representing both at once. This fundamental difference is what gives quantum computers their incredible potential. Next, we'll see how qubits are physically realized and manipulated in real-world quantum machines. Superposition is one of the most intriguing aspects of quantum mechanics. In simple terms, it means that a quantum system like a qubit can be in multiple states at once. This is very different from classical systems where things are either one way or another. Superposition allows quantum computers to perform many calculations at the same time, dramatically increasing their computational power. As we move forward, we'll see how this property is harnessed in practical quantum algorithms, setting the stage for breakthroughs in computing. Another key concept in quantum computing is entanglement. When two qubits become entangled, the state of one instantly influences the state of the other, no matter how far apart they are. This mysterious connection is a cornerstone of quantum computing, enabling powerful operations that are impossible with classical computers. Entanglement is what allows quantum computers to perform complex calculations with incredible efficiency. In the next scene, we'll look at how entanglement is created and used in quantum circuits. Qubits can be created using various physical systems, such as superconducting circuits, trapped ions, or even photons. Each approach has its own advantages and challenges. For example, superconducting qubits are popular because they can be easily integrated with existing electronic technologies. Trapped ions, on the other hand, offer high precision and stability. Scientists are constantly experimenting with new ways to build reliable and scalable qubits. Next, we'll explore how these qubits are controlled and manipulated to perform computations. Just as classical computers use logic gates to process information, quantum computers use quantum gates. These gates manipulate qubits through operations like flipping, rotating, or entangling them. Quantum circuits are built by connecting these gates in specific sequences to perform complex calculations. The flexibility and power of quantum gates allow for entirely new types of algorithms. In the next scene, we'll see how these circuits are designed and why they're so crucial to quantum computing. Quantum algorithms are specially designed to take advantage of the unique properties of quantum computers. Some famous examples include Shor's algorithm, which can factor large numbers exponentially faster than classical algorithms, and Grover's algorithm, which speeds up search tasks. These breakthroughs have huge implications for fields like cryptography and data analysis. As we continue, we'll dive deeper into how these algorithms work and what makes them so powerful. One of the most exciting promises of quantum computing is quantum speedup, the ability to solve certain problems much faster than classical computers. This is possible because quantum computers can explore many possibilities at once, thanks to superposition and entanglement. For example, tasks like factoring large numbers or simulating molecules can be completed in a fraction of the time. Next, we'll look at real-world applications where quantum speedup could make a significant impact. Quantum computing poses both opportunities and challenges for cryptography. While it can break many of the encryption methods currently used to secure data, it also opens the door to new quantum-resistant cryptographic techniques. Researchers are racing to develop algorithms that can withstand attacks from quantum computers, ensuring the security of sensitive information in the future. In the next scene, we'll explore other fields that stand to benefit from quantum computing. Quantum computers are particularly well suited for simulating molecules and chemical reactions. This could revolutionize drug discovery, materials science, and our understanding of complex biological systems. By accurately modeling interactions at the quantum level, researchers can design new medicines and materials much more efficiently. As we move forward, we'll see how quantum computing is being applied in other scientific disciplines. Machine learning is another area where quantum computing could have a huge impact. Quantum machine learning algorithms can process and analyze large datasets much faster than classical methods. This could lead to breakthroughs in artificial intelligence, pattern recognition, and data analysis. Researchers are actively exploring how quantum computers can enhance machine learning models, making them more powerful and efficient. Next, we'll look at the challenges facing quantum computing today. Despite its promise, quantum computing faces significant challenges. One of the biggest is error and decoherence. Qubits are extremely sensitive to their environment, which can cause them to lose information quickly. Researchers are developing error correction techniques and more stable qubit designs to overcome these obstacles. Solving these challenges is crucial for building practical, large-scale quantum computers. In the next scene, we'll discuss the importance of quantum error correction. Quantum error correction is a set of techniques designed to protect quantum information from errors caused by decoherence and other disturbances. Unlike classical error correction, which can simply copy data, quantum error correction must work within the rules of quantum mechanics. This makes it a challenging but essential part of building reliable quantum computers. Researchers are making progress, but there's still a long way to go before error correction is fully practical. Scaling up quantum computers from a handful of qubits to thousands or millions is a major engineering challenge. Each additional qubit increases the complexity of the system, making it harder to control and maintain. Researchers are exploring new architectures and materials to make large-scale quantum computers a reality. Overcoming scalability issues will unlock the full potential of quantum computing. Next, we'll look at some of the leading companies and institutions in this field. Several companies and research institutions are at the forefront of quantum computing development. Tech giants like IBM, Google, and Microsoft are investing heavily in building quantum hardware and software. Startups and academic labs are also making significant contributions, pushing the boundaries of what's possible. Collaboration between industry and academia is accelerating progress, bringing us closer to practical quantum computers. In the next scene, we'll explore how you can access quantum computers today. You don't need to be a scientist to experiment with quantum computing. Many companies now offer cloud-based access to real quantum computers. Platforms like IBM Quantum Experience and Microsoft Azure Quantum let users run quantum algorithms from anywhere in the world. This democratization of access is helping to educate the next generation of quantum programmers and researchers. Next, we'll look at the tools and languages used to program quantum computers. Programming a quantum computer requires specialized languages and tools. Some popular options include Qiskit, developed by IBM, and Microsoft's QHash. These languages allow developers to design and simulate quantum circuits, making it easier to experiment and learn. As quantum computing matures, we can expect even more user-friendly tools to emerge. In the next scene, we'll discuss the role of simulation in quantum computing research. Because real quantum computers are still limited in size and reliability, researchers often use classical computers to simulate quantum systems. These simulations help scientists test new algorithms and understand the behavior of qubits before running them on actual hardware. While simulations can't fully capture the power of quantum computers, they're an essential tool for advancing the field. Next, we'll explore the differences between classical and quantum computing. Classical computers process information using bits that are either 0 or 1, following well-established rules of logic. Quantum computers, on the other hand, use qubits that can be in multiple states at once, thanks to superposition and entanglement. This fundamental difference allows quantum computers to tackle problems that are intractable for classical machines. Understanding these differences is key to appreciating the potential of quantum technology. Quantum supremacy refers to the point where a quantum computer can solve a problem that is practically impossible for classical computers. In 2019, Google claimed to have achieved this milestone with their Sycamore processor. While the specific problem solved was highly specialized, it demonstrated the potential of quantum machines. The race is now on to achieve quantum supremacy in more practical and impactful applications. Quantum annealing is a specialized approach to quantum computing, used for solving optimization problems. Companies like D-Wave have developed quantum annealers that can tackle complex tasks like scheduling and logistics. While different from universal quantum computers, quantum annealers offer practical benefits for certain applications. In the next scene, we'll look at other types of quantum hardware. Quantum computers come in several forms, each with unique strengths and weaknesses. Superconducting qubits, trapped ions, and photonic systems are among the most popular. Each technology requires different engineering solutions and offers different performance characteristics. Researchers are constantly evaluating which approach will lead to the most scalable and reliable quantum computers. Quantum networking involves connecting quantum computers and devices using quantum signals. This could enable ultra-secure communication and distributed quantum computing. Quantum networks rely on entanglement and quantum teleportation to transmit information securely. As research progresses, quantum networking could become the backbone of a new, quantum-powered internet. Quantum teleportation is a process that allows quantum information to be transmitted from one place to another using entanglement. It doesn't involve moving physical objects but rather the state of a qubit. This technique is essential for quantum networking and secure communication. Quantum teleportation has already been demonstrated in laboratories, paving the way for future quantum technologies. Quantum sensors use quantum properties to achieve unprecedented sensitivity and accuracy. These devices can detect tiny changes in magnetic fields, gravity, or temperature, making them valuable for scientific research and practical applications. Quantum sensors are already being used in fields like medicine, navigation, and environmental monitoring. Next, we'll look at the impact of quantum technology on society. Quantum computing has the potential to transform society in many ways. From revolutionizing industries to creating new jobs and opportunities, the impact could be profound. However, it also raises important ethical and security questions. As quantum technology becomes more widespread, society will need to adapt to new challenges and possibilities. In the next scene, we'll discuss the ethical considerations of quantum computing. With great power comes great responsibility. Quantum computing could disrupt existing systems, from finance to national security. Ensuring that these technologies are used ethically and responsibly is crucial. Policymakers, researchers, and industry leaders must work together to create guidelines that protect privacy and promote fairness. Next, we'll look at how education is adapting to the quantum era. As quantum computing becomes more important, educational institutions are updating their curricula to include quantum concepts. Universities and online platforms now offer courses in quantum mechanics, programming, and engineering. This is helping to prepare the next generation of scientists, engineers, and entrepreneurs for the quantum future. In the next scene, we'll explore resources for learning more about quantum computing. There are many resources available for those interested in quantum computing. Books, online tutorials, and interactive platforms make it easier than ever to get started. Organizations like IBM and Microsoft offer free tools and documentation for beginners. Whether you're a student, professional, or hobbyist, there's something for everyone. Next, we'll look at the future outlook for quantum computing. The future of quantum computing is full of promise. As technology advances, we can expect quantum computers to become more powerful, reliable, and accessible. This will open up new possibilities in science, industry, and everyday life. While there are still many challenges to overcome, the pace of progress is accelerating. In the next scene, we'll discuss some of the most exciting predictions for the coming years. Experts predict that quantum computing will lead to breakthroughs in fields like medicine, finance, and artificial intelligence. We may see new drugs developed in record time, financial models that are more accurate, and AI systems that can solve problems beyond our current capabilities. While it's impossible to predict every outcome, the potential is enormous. Next, we'll look at how quantum computing could change the way we think about information. Quantum computing challenges our traditional understanding of information. Concepts like superposition and entanglement force us to rethink what it means to store and process data. This shift could have profound implications for everything from communication to privacy. As we adapt to the quantum age, new theories and technologies will continue to emerge. In the next scene, we'll explore the role of international collaboration in quantum research. Quantum computing is a global effort, with researchers and companies from around the world working together. International collaboration accelerates progress by sharing knowledge, resources, and expertise. Governments are investing in quantum research, recognizing its strategic importance. As the field grows, cooperation will be key to overcoming technical and ethical challenges. Intersection of quantum computing and artificial intelligence is an exciting area of research. Quantum computers could enable AI systems to learn and adapt much faster than today's machines. This synergy could lead to smarter robots, more accurate predictions, and new forms of creativity. Researchers are just beginning to explore the possibilities at this frontier. Financial institutions are closely watching the development of quantum computing. Quantum algorithms could optimize trading strategies, manage risk, and detect fraud more effectively. As quantum technology matures, it could transform the financial industry, making markets more efficient and secure. Next, we'll look at how quantum computing could impact healthcare. Healthcare stands to benefit greatly from quantum computing. By simulating complex biological systems, quantum computers could help develop new treatments and personalize medicine. They could also improve diagnostics and optimize hospital operations. As research continues, quantum technology could play a vital role in improving health outcomes worldwide. Logistics and supply chain management are complex problems that quantum computers could help solve. By optimizing routes and schedules, quantum algorithms can save time and resources. Companies are already experimenting with quantum solutions to improve efficiency and reduce costs. Next, we'll look at the environmental impact of quantum computing. Quantum computing could help address environmental challenges by enabling more accurate climate modeling and resource management. However, building and operating quantum computers also requires energy and materials. Researchers are working to minimize the environmental footprint of quantum technology, ensuring that its benefits outweigh its costs. Next, we'll explore the role of government policy in quantum development. Governments around the world are investing in quantum research and development. Policy decisions and funding play a crucial role in shaping the future of quantum technology. By supporting research, education, and industry partnerships, governments can help accelerate progress and ensure that quantum computing benefits society as a whole. Diversity is essential for innovation, and women are making significant contributions to quantum computing. From leading research teams to founding startups, women are helping to shape the future of this field. Encouraging diversity and inclusion will ensure that quantum technology reflects the needs and perspectives of everyone. Startups are playing a vital role in advancing quantum technology. These agile companies are developing new hardware, software, and applications, often in partnership with larger firms and research institutions. Their innovative spirit is driving rapid progress and bringing fresh ideas to the field. Open-source projects are making quantum computing more accessible to everyone. By sharing code, tools, and knowledge, the community is accelerating the pace of discovery. Projects like Qiskit and Circ invite contributions from developers around the world, fostering collaboration and learning. There are many myths and misconceptions about quantum computing. Some people believe it will instantly solve all problems, while others think it's pure science fiction. The reality is more nuanced. Quantum computers are powerful, but they have limitations and are best suited for specific tasks. Understanding what quantum computing can and cannot do is essential for making informed decisions. Quantum computing is a rapidly evolving field. Staying updated with the latest research, news, and breakthroughs is important for anyone interested in this technology. Following reputable sources and participating in online communities can help you keep pace with new developments. Quantum computing represents a new frontier in technology, with the potential to transform our world in ways we're only beginning to imagine. While there are still many challenges to overcome, the progress made so far is truly remarkable. By understanding the basics, staying curious, and embracing new opportunities, we can all be part of the quantum revolution. Thank you for joining us on this journey into the future of computing.